Alright, in lesson 1 of grade 12 trigonometry, we'll be introducing you to compound angles and deriving the formula for compound angles. So there's the basic 4 formulas for compound angles. We're going to show you how we got to this and how we're going to use them in the lessons that are coming. Alright, so in short, algebraic sum meaning when I add or subtract 2 or more angles, then we can refer to them as compound angles. So there's an example. If I say cos 60 minus 30, that's referred to as a compound angle, right? So if we calculate the values, cos 60 minus 30, I assume you know 60 minus 30 is cos 30, and cos 30 according to special angles would be square root 3 over 2. If we look at 1.2, if we try to expand this, cos 60 minus cos 30, 60 is a half, cos 30 is minus square root 3 over 2, right? 1 minus square root 3, and common denominator 2. We can only add two fractions if they have a common denominator. Right, so this answer and the first answer not the same. If I say cos 60 cos 30 plus sin 60 sin 30, cos 60 is half, cos 30 is square root 3 over 2, sin 60 is square root 3 over 2, sin 30 half. 1 times square root 3 gives me square root 3, 2 times 2 gives me 4, plus sign stays, square root 3 times 1 stays square root 3, 2 times 2 becomes 4. Square root 3 plus square root 3 give me 2 square root 3 over 4, and 4 goes in 2 twice, right? So square root 3 over 2, square root 3 over 2. So therefore we can conclude that cos 60 minus 30 degrees does not equal cos 60 minus cos 30, but cos 60 minus 30 degrees can same as saying cos 60 cos 30. You see cos cos plus sin 60 sin 30. So therefore in short, if we have cos any angle A minus any angle B, it will become cos A times cos B plus sin A sin B. So that's the first formula. It's not formally tested. This is much just showing you how via calculations we can prove that the two are the same. Alright, now in the next 3 slides we will be doing the formal proofs. Right, so yeah, in the first problem deriving the formula, we know from the previous slide that cos A minus B equal cos A cos B plus sin A sin B. Right? Now using this in exam we would say given this, derive the formula for cos A plus B. So that was A minus B, now I have A plus B. So I must write this with a negative, so cos A plus B can also be written as cos A minus minus B. Remember, negative times negative still gives me the positive. So therefore cos A plus B equal cos A minus minus B. Using the formula above, cos A minus B equal cos A cos B plus sin A sin B. We can expand this, so that would read cos A cos negative B. Minus becomes positive, and that becomes sin A plus sin A times sin negative B. Right? So I have cos A, negative B is in the fourth quadrant or negative angles. So cos negative in the fourth quadrant, cos is positive. There's sin A, sin negative B in the fourth quadrant, sin is negative. So that becomes negative sin B. This negative times that positive becomes negative. So I have cos A times cos B minus sin A times sin B. So in short, cos A plus B, cos A cos B minus sin A sin B. So what cos compound angle, negative become positive, positive become negative, but it always stays cos cos, sin sin. So hope you follow and understand. Alright, second formula to derive. Given again cos A minus B equal cos A cos B plus sin A sin B, we will be required to derive the sine compound angle. So if sin A plus B, sine can be written as cos, provided it's 90 minus. So remember, co-functions or co-rule, cos 90 changes to sine. So there, 90 minus a plus b. Take the a out, that becomes negative a, negative b. Then I group 90 minus a is one angle and b is a second angle. So there, instead of having a, I have 90 minus a and my b is b. So again, the compound angle in this case only two angles. Right, so using compound angle for cos, we would have the cos 90 minus a cos b. Remember, minus becomes plus. That gives me sine 90 minus a and sine b. Right? Cos 90 minus a falls in the first quadrant, but 90 changes cos to sine. In the first quadrant, everything is positive, so that becomes sine a. Cos b, simply stay cos b. Sine 90 minus a, first quadrant, everything is positive, but sine changes to cos. That becomes cos a sine b. So therefore we can conclude that sine a plus b equals sine cos cos sine ab ab. Right? So whenever it's sine, it will be sine cos cos sine. Right? The last one, let's go to the last one to derive. Alright, and if you're enjoying the lesson so far and you're understanding, please like, share and subscribe. Right, I'm doing this, I'm not charging you for anything. I'm trying to help learners, but yes, I need subscription. Right, so sine a plus b equals sine a cos b plus cos a sine b. Right, so to derive the formula for sine a minus b, you can write this as sine a plus negative b. Using the above, that would become sine a cos negative b plus cos a sine negative b. Negative angle in the fourth quadrant, so cos negative b would simply stay cos b, but sine negative b becomes negative sine b in the fourth quadrant. Right, so that negative times that positive would then make this negative. So therefore we have the formula sine a cos b minus cos a sine b. So sine a minus b equals sine a cos b minus cos a sine b. So hope you follow. Those are just the formulas. The next lesson we'll be using these formulas to expand.